man-child with atomic mechanics child. This is my quantum gravity video 38. Today's topic is a further and more explicit explanation on the cosmological constant problem, or abbreviated to be CCP. And my proposed solution in video 33. In video 33 of this series, I proffer an alternative solution of a cosmological constant problem, CCP. Looking back, my proposed solution appears to be not spot on. It's off the mark and may even be puzzling. The CCP refers to the problem due to a discrepancy of an astounding 10 to the power 122 between the figure computed using the effective quantum field theory and a dimensional analysis method. And the discrepancy is between this and the ratio of the density actually observed value of omega, which means the matter or energy density of all matter, including principally the dark matter, and the cosmological constant, which is presumed to be equal to the dark energy. The ratio of this to the critical density. The critical density is between 1 times 10 to the power minus 26 kilogram per cubic meter to 2 times 10 to the power minus 26 kilogram per cubic meter. But in my video 33, I only gave a value calculated based on the reasoning in my video 16 and video 28, even though the set value is actually a near match, that is of the same or nearly the same order of magnitude as the omega. So it may not be clear how my proposed solution in video 33 is a solution of the CCP problem. Therefore, I need to explain here in this video 38 in a more explicit manner and in greater details. First, let's see in my video 33, my proposed solution. And there I calculated according to a formula of me, and that arriving at the value of 0.20153 times 10 to the power minus 26. So it's a very near match to the omega, the actually observed value. But if I only gave this calculation, and it's puzzling why I have solved the cosmological constant problem. So I have to explain in further details and more explicitly. The cosmological constant is often referred to as lambda. Lambda, Greek letter. In many books on astrophysics. Here I will quote from the Mapping the Heavens, a book by Lamda Natarajan, an Indian lady astrophysicist of Yale University, as 2016 edition on page 138 to 140. She says, so omega is really down to the contribution from all matter and the contribution from lambda. That to say, omega actually is a sum of these two quantities. One is the contribution from the all matter. The other is the contribution from lambda. The lambda, as explained above, is often thought to be equal to the dark energy. And they said that further says in the 1980s and the 1990s, astronomers found that the matter density omega of the universe is about 0.3. Measurements of the fluctuations in the CMBR, that means the cosmic microwave background radiation, detected by COBE, which means the cosmic background explorer, one of the satellite telescope. In 1980, gave the omega is equal to 1. And here was a puzzle. What accounts for the missing 0.7 in omega? And the 0.3 measurement of omega is that which includes the contribution from all, both visible and dark matter, It suggests that the universe is perpetually expanding with a slight slowdown or deceleration. And a handy way to reconcile the COBE estimate of omega with that inferred by measuring the density of the galaxies. If the value of the cosmological constant is 0.7, then everything fits. If that is to say, if the value of the lambda, the cosmological constant, is equal to 0.7, and the value measured in the 1980s and 1990s of the omega is 0.3, then 0.7 plus 0.3 is actually 1, equal to 1. That means the omega equal to 1 is good fit. It's fully explained. But it also says a tipping point universe with an omega equal to 1 is a very special case. It corresponds to a flat geometry on the larger scales. At the end of quote, this is my quote from the book, Mapping the Heaven. Now please note that the 0.7 is of the same or nearly the same order of magnitude as 0.3, and the computed value is derived from my video 33, 0.20153 times 10 to the power minus 26 kilogram per cubic meter is of the same or nearly the same order of magnitude as omega, whether omega is equal to 0.3 or equal to 1, because 0.7 is of the same order of magnitude as 0.3 and 1, and which is, as I said before, is 1 to 2 times 10 to the power minus 26 kilogram per cubic meter. Both are of the 10 to the power minus 26 kilogram per cubic meter, and one is my calculated value is only 0.20153, and the actually observed value is 1 to 2 times 10 to the power minus 26 kilogram. So it's only about, let's say it's about 5 to 10 times less than the actually observed value. So the computed value in video 33, in my video 33, can easily be reconciled with the omega, whether it is 0.3 or 1. Why? Because in video 33, the equation in this section, that is including both the radiation emission amount and the number of years of emission are estimated. There is reasonable belief that both these figures were underestimated because the most recent Wilkinson microwave anisotropy probe survey results, or abbreviated WMAP survey results, and the recent JWST, that would say James Webb Space Telescope survey result, both tend to increase these two figures. Why? Because this the WMAP survey result is increasingly says reported that the number of galaxies and number of stars is increasing, is on the increase, because the further they can see, the more galaxies, the more stars they can survey. And also from the same reason, from the JWST, it says more and more galaxies became visible in the survey, and then the farther and farther back they can look at in the universe. So more and more galaxies, more and more stars became into the visible range, and so that means more and more radiation emission, and then the also number of years of emission is also increased, because the farther back meaning the longer period in the history of the universe they can survey. Thus, the update, if the figures are updated, then it should be even much more nearer to the actually observed omega and lambda. But now, as I said, the figures here is only about 5 to 10 times less than the actually observed value. If the number of galaxies and stars are on an increase, then and the further and further back the JWST, the James Webb Space Telescope, can look back, in time, then the number of years emission will be increasing, also on the increasing. So the net result will be that the updated figures will be more and more near to the actually observed value, and also that is to say there may be nearer and nearer to the ratio between lambda and omega, that is to say 0.7 to 0.3, which as I mentioned above, is a good fit. If the lambda is of 0.7 and the omega is of 0.3, then it's a good fit. Thus, the value computed based on the radiation energy emitted by all the stars and galaxies and Seyfert galaxies, the black holes, supervised lovers, and the Seyfert galaxies, etc., over the period of history of the universe, is a good match for lambda, the cosmological constant, which is presumed to be dark energy. This, in fact, given in my video 28 and video 16. In video 16, I firstly mentioned that the emission from stars and galaxies. But of course, at the time, it's almost 2 years ago, video 16. So at the time, the number of stars and galaxies was underestimated. And then the radiation spread out and becomes cooling down. The further it spread out, the wavelength becomes longer and longer, the temperature becomes lower and lower. And then lastly, I refer to the Worley theorem. That means under effect of gravity, the Worley theorem collapses the radiated emission of radiation until they become Planck black holes, which is of course my main theory. And then Planck black holes, part of which firstly become dark matter. And finally, they become hydrogen atoms. This is my Planck black hole theory and new hydrogen atom model. Here. The stars, radiation emission, and then become collapse under gravity with cold dark matter, cold dark radio waves collapsed under the Worley theorem, or the Oppenheimer-Volkoff equation, which is the equivalent, into Planck black holes. My videos 2, 3, and 4, and then it becomes hydrogen atoms, and hydrogen atoms under the conventional, traditional astronomical theory will undergo a process to become stars. Firstly become nebula, star-forming nebula, and then within a star-forming nebula they'll become stars. And stars will again emit, emits the radiation. So it's back to square one. So this is my cycle. It's a very short and very simple cycling of the evolution of the universe. This is my Planck black hole theory. The evolution of universe under my Planck black hole theory, on the basis of my Planck black hole theory. So what about the value? So what about the value calculated by the physicists for lambda, that should say the dark energy, which is presumed to be a dark energy, always using the computed, using the effective field theory, with the quantum field theory, and dimensional analysis, etc., which match with the cosmological constant problem. Einstein himself admitted openly that the cosmological constant lambda was arbitrarily plugged into his field equation in 1917. He in 1917 admitted this. This is quoting his words, without any theoretical mathematical basis relating to the law of gravitation. That the lambda is necessary only for the purpose of making possible a quasi-static distribution of matter as required by the fact of a small velocities of the stars. This is from page 35 of Mapping the Heavens, quoted, the book I just mentioned earlier. And Einstein later abandoned lambda, means that upon his abandoned the lambda upon being shown the Evan Hubble's observational results. This is in 1929. This means that Einstein did not have any idea how lambda arose or what it was. He later reserved his position by saying that the issue of lambda requires better observational data in future to clarify. Therefore, using any mathematical method to compute something which Einstein himself admitted he did not have any idea of theoretically or mathematically is not appropriate and might have thus caused the difficulties. By difficulties, I mean the 10 to the power 122 discrepancy. So final conclusion is the cosmological quantum problem arose due to inappropriately using the mathematical or theoretical methods to compute something which was formerly admitted by Einstein that he had no idea as to its theoretical or mathematical basis. On the other hand, using the method of emission of radiation energy, which I just explained briefly, as depicted in my video 16, 28, and 33, is pursuant to the further and better observational data of the Wilkinson microwave anisotropy probe WMAP survey results. The COBE, the cosmic background ray explorer, just which I just mentioned earlier here, COPE. And then the JWST, the James Webb Space Telescope survey results. And this is a good theoretical description, which gave the near. The remarkable thing is that it gave the near match result, which can easily be reconciled with the 0.7 to 0.3 of the ratio of the omega. As this method is based on my Planck black hole theory and my new hydrogen atom model, this fact proves the correctness of my theories and the model. So today my video finishes here. So if you are interested, you can subscribe and like.